The title of this presentation is the Northeast Coastal Ocean Forecast System, also known as NECOFS, a coastal inundation forecast system for predicting coastal flooding from past and future extratropical nor'easter storms. The authors of this presentation are Changshen Chen and Qishun Qi of the University of Massachusetts at Dartmouth, Robert Beardsley of the Woods Hole Oceanographic Institution, and Tom Shyka of NERACOOS. The primary funding for this effort has been provided by the U.S. Integrated Ocean Observing System. The key drivers for this project include the fact that many areas of the U.S. Northeast coastline are extremely vulnerable to storm-generated inundation, and also that projected sea level rise will certainly exacerbate this serious coastal hazard. Some of the primary research questions of this project include: how do you develop an end-to-end forecast system for storm-induced coastal inundation? How will predicted sea level rise impact storm-induced inundation in the U.S. Northeast coast? And how important is current wave interactions for coastal flooding? The academic disciplines represented in this project include physical oceanography, along with marine scientists with training, experience, and stakeholder engagement. There have been a variety of stakeholders engaged in the development of NECOFS. The specific stakeholders engaged in the coastal inundation component of NECOFS include state coastal zone managers, state and local emergency managers, and forecasters from the National Weather Service regional forecast offices. The engagement activities have included facilitated focus groups, online surveys, interviews, and informal interactions at a variety of meetings. Stakeholder engagement is ongoing as we continue our work to improve the delivery and use of predictions from NECOFS. The core services provided by this ongoing effort include a sophisticated atmosphere-ocean wave modeling system, a THREDDS catalog for access to standardized model output, and data viewers for the visualization of the model output. Next, I'm going to provide some more detail about these core services. The primary core service developed by this effort is the NECOFS modeling system. This system was developed for NERACOOS by Changshen Chen of UMass Dartmouth and Bob Beardsley of the Woods Hole Oceanographic Institution. This atmosphere-ocean wave modeling system includes a regional weather model, WRF, and a regional hydrodynamic model, FVCOM. Both WRF and FVCOM include data assimilation from satellites and buoys. The system also includes a surface wave model and several high-resolution storm surge inundation models for coastal areas that typically experience inundation during a coastal storm. NECOFS has been in operation since 2007 and produces a 3-day hourly forecast every 24 hours. This slide illustrates the system of nested model domains within NECOFS. On the top center, the black gridded area represents the regional domain of FVCOM. The red boxes represent the domains of the regional weather forecast model, WRF. Along the bottom are the high-resolution domains of the coastal inundation models. These models include wave current interaction. The location of these domains were determined through discussions with key stakeholders, including the state coastal zone managers, emergency managers, and regional weather forecast offices. Another core service provided by this effort is a THREDDS data catalog, which provides open access to standardized model output files. Model visualization capabilities are another core service provided by this effort. These tools allow users to visualize the model output in a variety of formats. The Model Viewer tool developed by UMass Dartmouth is available at the URL on the bottom of this slide. The Forecast Viewer allows a user to generate custom maps of forecast predictions. The maps illustrated here represent predictions from a 2018 nor'easter. The forecast viewer can also generate maps of inundation predictions from the high-resolution coastal inundation models. The model viewer also allows the user to compare observations to model predictions. The plots on the left show a comparison of buoy data to the model predictions. The red lines represent buoy observations and the black lines represent model predictions. The plot on the right shows a comparison of water level observations to water level predictions. The red line represents observed elevation. The blue line represents predicted tidal elevation. The black line represents total elevation forecasted by NECOFS. And the light blue line represents the residual elevation. The IU's Model Viewer is another core visualization service. This model viewer, developed by RPS for the IU's program office, includes the model output from NECOFS as well as the model output from a variety of other IU-supported regional models. This viewer also includes the output from a variety of federal models. Users can examine several modeled variables together in a map-based environment and generate time series plots of the output. Real-time observations are also available for comparison purposes. This viewer can be accessed through the URL at the bottom of this slide. The key successes of this effort include the continuous operations of NECOFS since 2007, the open access to standardized model output through the THREDDS catalog, the broad use of the model predictions by local, state, and federal stakeholders, incorporation of high-resolution wave current inundation models at the flood-prone coastal regions, and a series of improvements including larger and higher resolution grids, data assimilation, and extending the forecast window. Also, the core services provided by this project have supported a variety of other coastal modeling projects in the region. The missing expertise from this effort includes the social sciences, which could help the project team better understand the stakeholders' decision-making process and how they interact with data in that process. This information, along with product development and design expertise, could help improve the delivery and the use of the information by the stakeholders. Some of the remaining challenges of this ongoing project include improving the delivery of products and services for the stakeholders. Also, transitioning a component of the modeling system to NOAA's National Ocean Service, and improving the technique for the prediction of coastal inundation due to wave run-up induced splashing or overtopping. Thank you for the opportunity to provide this presentation. For questions about the modeling system, please contact Changshen Chen at UMass Dartmouth. And for questions about stakeholder engagement, please contact Tom Shyka at NERACOOS.